Okay, well, I'm going to do a review. I'm going to work some of the problems on the review. So, class, we're going to have a vocabulary test, a systems test, your review, which we're going to work half the problems is due. This is not late. We're no late except no late papers. And your color sheet and your worksheet reviews will not be accepted after the test date. Mixed up answers will be on Canvas and they'll be at the end of this. And then extra credit, you can do your 4 square of the 29 vocabulary words for extra credit. Alright, so let's get started. I'm just going to work the odd problems. So, number 1, we're going to solve each system by graphing. So when I look at this, I see that y equals 4x minus 1. My y-intercept is minus 1. My slope is 4. So I'm going to go to minus 1, plot that point. My slope, so that's what, when x is 0, y is minus 1. My slope is 4 over 1, so this is my rise. This is my run. So I'm going to take this point. I'm going to move up 1, 2, 3, 4, positive 4, and over 1. Now, you guys are now getting to the point where you can do this both ways, that a positive 4 over a positive 1 is going to be the same as a negative 4 over a negative 1. So I can go from this point and go down. Just like if I was starting here, if I went down 1, 2, 3, 4, I could go to the left one. I can do that again. 1, 2, 3, 4, and over to the left one. So that I have a point on both sides of my y-intercept. And I'm going to take my ruler and graph. So there's my first line. That's my green. Then I'll do orange. And my y-intercept is 2. So when x is 0, y is 2. And my slope is the number in front of my x. So that would be 1. So my slope is positive 1. So I'm going to go to positive 2, plot my y-intercept. I'm going to go up 1 is my rise, over 1 is my run. Plot that point. I'm going to also then go down 1, negative, and over to the left, negative. Negative over negative is a positive. I'm going to draw that line, and I see that they intersect at this point right here, which is which is x, 1, 3. So that's the solution for number 1. You guys can work number 2. Number 3. These I need to put into slope-intercept form. They're in standard form. Ax plus by equals c. I need to put that into y equals mx plus b. The first thing I'm going to do that is move my x. So if I take 8x minus 3y equals negative 12 and move my x over, I'm going to move this whole term. So in order to do that, I'm going to subtract both sides by 8x. I want to not just 8, I'm moving the whole term with the x as well. Subtract by 8x. When I subtract 8x, subtract from 8x, I get 0. I've done nothing to my 3y, so I just bring that down, equals. Now I have negative 12 minus 8x. I cannot combine them. That does not equal 20x, negative 20x. Or it doesn't equal 4x. I cannot combine these two because this is a number without a variable. This is a number with a variable. So I just put them side by side, and I'm going to say negative 8x minus 12. That's as simplified as they can get. So my next step is, since this is 0, I'm not going to do anything with that. I'm going to divide by the coefficient of y, because my goal is to get y by itself. I'm solving for y. I'm going to divide by negative 3, and I get y equals positive 8/3 x. Negative over negative is a positive. 12 divided by 3 is 4. So we're going to keep this in fraction form because this is my rise, this is my run. When I talk about rise over run, what I'm saying is this is the difference in my y numbers, this is the difference in my x numbers. So to graph it, I'm going to go up to 4, and then I'm going to graph it. Now, if I were to go up positive 8, I would go way off the graph. But look I can go negative 8 over negative 3. So that means I can go down 1, 2, 3, 4, 5, 6, 7, 8. But then I have to go over negative 3. So that is this to the left. 1, 2, 3. So here are my 2 points. I'm going to connect my dots. So there's this equation graphed. My next equation, 8x minus 3y equals 6. I'm going to do the same thing. I'm going to subtract 8x from both sides, and I'm going to get negative 3y equals, and again, I cannot combine these two together, so they just fit nicely side by side, plus 6. This is a positive 6 since there's no negative in front of it, so we do the plus 6. Then we're going to divide by negative 3, and I get y equals negative or positive 8 over positive 3x positive 6 divided by negative 3 is negative 2. So in this situation, my b is negative 2 and my slope is 8 over 3. In this one, my b is 4, meaning when x is 0, y is 4. And my slope is 8 over 3. So when x is 0, y is negative 2. It's kind of a mess. All right, but you know what I mean. So when x is 0, y is negative 2. And I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. That's off the grid. Over 1, 2, 3. But right now, you should be saying that you know you see something. And what is it that you see? You should notice that the slope is the same for both lines. And we know that when the slopes are the same, that those lines are going to be parallel. So we've got 2 parallel lines. So there should be no solution. Okay. You should be able to work this one on your own. Okay. That is the same type of thing. You change it into standard, or from standard form into y-intercept form. Moving on. So now we're working with inequalities. We've got y is greater than 4x plus 2. So the first thing I'm going to do is figure out my y-intercept is 2, which means when x is 0, y is 2. So I can plot that point. I'm going to look and find my slope. The slope is the number in front of the x when it's in slope-intercept form. So that is 4. So I'm going to go up 4, 1, 2, 3, 4. That goes off the grid. So what can I do? I can go -4 over -1. Because a negative over a negative is a positive. These are all equal to each other, so we can do that. 1, 2, 3, 4, and to the left 1. We connect our dots. And I'll show you, had we kind of close. Had we gone off the grid 1, 2, 3, 4 over 1, that would have given us a point right about there. Okay. So, now I've screwed up. What did I do wrong? You should be saying, Ms. LaBelle, you did something wrong. What did I do wrong? I notice now that this is a greater than, but not equal to. So I need to get my y out and dot my line because it should not be a solid line. It should be a dashed line. It should not be solid because it's not equal to. It's only greater than. So make sure that you don't make that mistake on yours. You should be seeing my mistakes, right? All right. Now, since y is greater than, we are going to look and see y gets bigger when we are here. Y is bigger here. So everything gets shaded above the line. That shows me that y is greater than the points on that dotted dashed line. Okay, my next problem is y is less than x minus 1. So my b is -1. My slope is, the number in front of my x is 1. My slope is 1. So I'm going to come down here to -1. I'm going to go up 1 over 1. Or I can go down 1 to the left 1. Now I'm not going to make that mistake again. I'm going to dot my line since this is y is less than but not equal to. I'm going to make my line dashed to show that I'm paying attention. And I now need to go y is less than. So for that line, I would highlight or shade since y is less than everything below that line. So that means everything below that line gets shaded. So what is it that is shaded twice? It is this area right here. This area right here is shaded twice. That teeny little area. Those are where your solutions are. So you should be able to do this one. Okay. If you have any questions, by all means, come see me. Okay, moving on. Let's do, you should know when x equals a number, is that a horizontal or a vertical line? Think about that. X is always 1. I'm not going to do that one for you. You guys do that one. We'll do this one. No, I'm not going to do that one for you. Here, we'll do this one. All right. Or should you do both? Maybe you should do both. All right, I'll do this one. In order to move your numbers, what do? The first thing you do is change it. Change from ax plus by is c to y equals mx plus b. So we need to move our x. So we take x plus y less than or equal to -1. We subtract x from both sides, and we get y less than or equal to negative x minus 1. Okay. I think I'm going to be done with that. So that's how you should do that. Your y-intercept is negative 1, and your slope is negative 1. I think you guys should be able to work it from there. Moving on. I'll tell you the answer, though. You'll have to give me the, they would intersect at 1, negative 2. Okay, moving on. Let's do some elimination. So, when we are looking at elimination, what do? The first thing we do is look to see, is there a variable with the same number or coefficient? And does it have a different sign? Why are we doing that? We are trying to eliminate. We are trying to get rid of one of the variables. We're trying to get rid of either the x or we're trying to get rid of the y. So we look at this and we see, oh, 5 in front of x, 5 in front of x. This is negative. This is positive. Same number, 5. Different sign, positive, negative. Perfect. Then you're going to add them together. Add together. Negative 5 plus 5 is 0. Positive 9 minus negative 9y is 0. Negative 3 plus 3 is 0. 0 equals 0. That is a true statement. So we have infinitely many solutions, meaning same line. All right. Let's move on to another one. Why don't we do number 15? Well, here we can do number 12. Let's do number 12. We've got different number, same number, but the same sign. So we have this different numbers here, so we are going to look and see what our y has. We have the same number here, so that's good. But we have different signs here, or the same signs, and we want a different sign. So in order to make it a different sign, I'm going to multiply by negative 1. That's going to effectively change all of my signs. So I get negative 2x plus a negative times a negative is a positive 2y equals a negative times a negative equals 12, positive 12. Then we have 3x. I haven't done anything to this. I don't need to do anything to this second equation. This second equation is exactly the way I want it. Sorry about that. This second equation is exactly the way I wanted it. So I multiplied this negative 1. I've changed the sign, sign, sign. Now this equation is exactly how I want it. So I'm not going to do anything to that one. Then I add them together. Negative 2x plus positive 3x is 1x. Positive 2y minus negative 2y is 0. So they cancel each other out. We have eliminated that, which is exactly what we want. Positive 12 minus 17 is negative 5. But look at, so we just get x equals negative 5. Perfect. So in my solution, I know I've got negative 5 here. What about my y? I have to take my negative 5 and put it in for my x. So here I'm substituting this negative 5 for this x. And just like you would in using the substitution method, you just plug it in. You take the x out and you put the negative 5 in. So you go 3. I'm taking the x out, so I'm not even going to write an x. Minus 2y equals negative 17. What am I going to put instead of that x? There's a blank right here that I need to fill with something. The x goes there, but instead of that, I'm going to put in this negative 5. So now I am left with only one variable. 3 times negative 5 is negative 15 minus 2y equals negative 17. Then I add 15 to both sides because I want to get that y by itself. What I need to do is get rid of this. I'm looking to get that y by itself. So I'm going to move this number over to this side because I want to get the variables on one side, the numbers on the other side. When I do that, I'm going to move that over here. And I'm going to get negative 2y equals negative 2. Because negative 17 plus 15 gives me negative 2. Then I divide by negative 2 because I want to get that y by itself. And I get y equals 1. So when x is negative 5, y is 1. So my solution, just checking my answers, my solution to number 12 should be x negative 5, y 1, box, and move on. Alright, moving down to number 15. Here, I have a 7 in front of the x and a negative 5 in front of the x. Then I have a 9 in front of the y and a 7 in front of the y. I do have 14s here, but that's not going to help me. I need to get rid of one of these x's and y's. So I'm going to need to multiply by something. Now this time, it doesn't seem like I can multiply by one equation. Looks like I'm going to have to multiply both equations before I can get something. There's no easy number that's going to go into both. So the way I see it is I'd like to keep it as small numbers as possible because they're easier to work with as far as I'm concerned. So I'm going to take, I know that 7 times 5 is 35. So if I multiply the top equation by 5, I will have 35x. How do I know that? Because I know my math facts. However, if I look at this number in front of my x and I just multiply that number times there, and then I multiply my lower times here. So do you see? Here is my 7. I'm multiplying that there. Here is my 5. That way I know I will get them both to be the same number. 5 times 7x is 35x. 5 times 9y is 45y. 14 times 5 is, I think it's 90. Let me see. Let's see. 14 times 5. Oh, 70. Okay, oops. 14 times 5, 70. I need to work on my math facts. So now I've got 7 times negative 5 is negative 35x. So here, look at this. I've done what I needed to do. I've gotten my same number, different signs. So this is exactly what I'm looking for. 7 times 7 is negative 49y. And 7 times negative 14 is negative 98. So when I add them together, this crosses out. 45y minus 49y is going to be negative 4y. Then when I say 70 minus 98 will give me 28, negative 28. I can do it on my calculator if you want. Negative 98, or here, let's do 70 minus 98, or 70 plus negative 98. Either way, you get negative 28. Then I'm going to divide both sides by 4, negative 4, because I want to get rid of that negative as well. Y equals 7. All right. 28, oops, divided by negative 4, 7. So when y is, so I can put up here, y is 7, and now I need to plug that back in, so I can have negative 5x minus 7. I'm not going to put that y back in there, because I'm going to substitute something else in there instead. I'm going to take this green 7 and put it in there for the y. So I get negative 5x minus 7 times 7 is 49 equals negative 14. Add 49 to both sides. And I get negative 5x equals, well, we'll do that one. It's going to be 30. Let's see. Negative 14 plus 49. 35. Divide both sides by, divide by negative 5. And I get negative 7. Oops. Oh, x equals negative 7. Alright, so here you go, guys. Now, not once have I checked my work other than to look. So let's check my answers. If we throw 7, negative 7 in for here and 7 in for there, let's see how quickly we could do this. 7 times what my x is, negative 7, plus 9 times 7 equals 14. Oops, 14. So I can see that I've plugged in, can you see that? I've plugged in my x and my y, and I got it correct. It should work for both. So let's see, negative 5 times my x, which is negative 7, minus 7 times my y, 7 equals negative 14. So I know I got it correct. It's the easiest way to check your work. Alright, moving on. Now we will solve by substitution. This is where you plug your numbers in for your x. I want you guys to really think about what you're doing. I've got y equals and y equals. So if I take my y equals this and y equals that, we know that y equals each other. So, negative 4x minus 9 is going to equal y. Right? Isn't that what they say? And y is going to equal negative 2x minus 3. These are the same numbers. They are the same. I'm going to write that. Same. So what they're saying is if y equals this and y equals that, and these two should equal each other. So we can write that. Negative 4x minus 9 should equal negative 2x minus 3 because they both equal y, which is the same number. Same number. So now I just have to solve for x. How do I do that? I want to get my numbers on one side and my variables on the other. So I'm going to move my x to one side and my numbers to the other. So if I add 2x, negative 2x minus 9 equals, this equals 0, minus 3. So now I've moved all my x's to this side. So now I need to move my numbers to that side. How I'm going to do that is I'm going to add 9, and I get negative 2x equals negative 3 plus 9 is 6. I'm running out of room, but I get negative 2x equals 6. And up here. Divide both sides by negative 2. I want to keep my x there, so I'm not going to move my x. I just want to get rid of the number in front of the x being multiplied by the x. So the opposite of multiplication is division. And negative 2 over 2 becomes 1. So I get x equals 6 divided by negative 2 is negative 3. So I get negative 3 here. Now I need to figure out what my y is. In order to do that, I'm going to plug in this x value into either one of these equations. It does not matter which one. They both should work out the same. So I'm going to plug in this negative 3. I'm going to take, let's just say y equals negative 4. And I'm not going to put an x because I have a number now. And that number is negative 3. So y equals negative 4 times negative 3, 12 minus 9. 12 minus 9 is 3. So when x is negative 3, y is positive 3. So here's my answer. It's a long mess. Sorry. Hopefully that'll help. Let's do one on the back. Now, what you're going to look for, what I want you to write down on your paper, look for x or y without a number in front of it. This is what I want you to look for. Sorry. look for an x or a y without a number in front of it. That will make your life a lot easier. Okay, right here you are given y equals. So this right here, you know you can substitute this for that y. Is there any others that you are given? Nope. So the rest of them you're going to have to find. Okay, if you don't have one of those, then you're going to have to solve for x or y. And you're going to solve for the one that doesn't have a number in front of it. So for an example, in this one, I would solve for the x. The x doesn't have a number in front of it. That's going to be far easier to solve for. In this one, neither one has a number in front of it. That will be very easy. In this one, do you see one that doesn't have a number in front of it? That's the one you should be solving for. Same with this one. Which one of these does not have a number in front of it? That's the one you should be solving for. So let's do one of these. Let's do number 20. So since I'm going to solve for this x minus 3y equals 11. In order to solve for x, the first thing I'm going to do is move the other variable. So if I'm solving for x, I'm going to move my y. If I'm solving for y, I'm going to move my x. I want to get my x and everything on one side. Move so x or y is by itself. So I'm going to add 3y to both sides. And I get x equals, is that 14y? You should all be shouting no. I cannot combine those because this has a y and this doesn't. So it's 3y plus 11. So now I have x equals something. That's good. That's what I want. So now, since I know what x equals, it equals this whole thing. So I can substitute wherever x is, I can substitute this. So I'm going to come over here and I'm going to say negative 3. And before there was an x there, but I'm not going to keep that there, equals minus 5y equals negative 19. I need to put in what goes in there instead of x. What is it that goes in there? I get rid of that x. I take him out of the equation. He no longer belongs. And I'm going to add 3y plus 11. That's what goes in that box. So then I distribute negative 9y minus 33 minus 5y equals negative 19. Then I am going to combine my like terms. Don't forget to combine your like terms. Combine. I've got two sets of y's here that are just hanging out. I can combine those together. When I combine negative 9y minus 5y, I get negative 14y minus 33 equals negative 19. Okay, so now I've simplified, but I still need to get my y by itself. So I need to move my numbers over here. I'm going to add 33 to both sides. And I get negative 14y equals negative 19. What do we have here? Negative 19 plus 33. Look at that, it's 14. When I divide both sides by negative 14, I get y equals negative 1. So then I know that my answer is going to have negative 1 here. But I still have to figure out what my x is. Well, I know that x equals this. I know my y equals this. I can put this right there. So I can get x equals 3 times, let's use yellow. So here's my y, here's my y, here's my y. And instead of y plus 11, I'm going to put this right where my y should be, negative 1. Do you see how my y is no longer there? I've gotten rid of it. I've substituted it in. I don't have another y. I don't have a y in here anymore. Once I substitute it in, do you see how when I substituted this in for my x over here, I no longer have an x. I no longer have y. It's gone. Bye-bye. So x equals negative 3 plus 11. X equals 8. So my answer to number 20 is 8, negative 1. Okay? But make sure you notice that once I substitute this in, that x is gone. Once I substitute this in, that y is gone. Okay. Let's see. That should be it for now.